Greetings everyone, my name is Farrell Liam and today I'm gonna present to you guys about metal forming processes. Most of my reference I took it from the Handbook of Manufacturing Processes, how products, components and materials are made, and made by James G. Bralla. So now I'm gonna present you guys about three topics here. The first one is wire forming operations, the second is tubing and section operations, and the third one is non-sheet forming operations. So let's get into the first one, wire forming operations. Wire forming is a method for applying force to change the contour of wire by bending, swagging, piercing, chamfering, shearing, or other techniques. In many other applications, wire can provide an economical configuration, sometimes with a spring effect incorporated and sometimes as a rigid member. I'm going to show you how the wire forming method is processed. So here's the bending machine for wire forming. The wire flow into the hole and the machine bend the wire. After the wire is bent, the machine cut off like this. That is how the process of wire forming method. Okay, so let's go to the next one. Manual forming of wire parts. Wire can be bent with hand-powered bending brakes, cake presses, or various fixtures with hinged or pivoted elements, since force required are low. Hand bending may be applicable when quantities are limited. Forming in 4-slice machine. Wire can be formed in the 4-slice machines too. This method is applicable to parts formed from wire or sheet metal strip. 4-slide machines have a forming area with 4 press slides set 90 degrees apart and driven by cams. Tools on the side designed to blank, pierce, notch, bend, form, emboss, and cut off the wire or strip as it progresses through the machine. So this is the part where the wire cut off. This is a video of the process of 4-slide machines. There's advantages of 4-slide metal stamping. A 4-slide metal stamping machine is essentially a horizontal stamping press with tools controlled by a series of cams. The slides are driven by 4 shafts connected by a series of beveled gears. One shaft is powered by an electronic motor which in turn drives the shafts of the other slides. Each slide is equipped with a tool that strikes the workpiece from 4 orthogonal horizontal directions to form the final product. This arrangement allows the workpiece to be worked on 4 sides with precision and repeatable accuracy. There's the benefits of 4-slide metal stamping. 4-slide metal stamping or 4-slide machines perform several operations almost simultaneously. As a result, for certain parts, the process requires less handling, fewer machines, and fewer secondary operations. In progressive stamping, material is needed on either side of the strip for the die to punch through the metal sheet. With 4-slide methods, however, the material can be purchased at a specified width, resulting in less working material and greater cost efficiency. Okay, let's go to the next one. The next one is a spring forming. As you can see, the wire come out from the hole and the machine bend and roll the wire. So it makes like a spring and the machine cut off the wire, just like this. Okay, basically that's how the spring forming operations work. Now I want to show you the next one. The next one is Turk's head rolling of wire. The process is used to change the cross-section of round wire. Rectangular, square, and special shapes can be imparted to the wire by passing through opposed rollers arranged so that opening between them is the shape of the cross-section desired. So this is the machine. The wire goes into the middle of this hole. From the cross-section of round wire became a rectangular, square, or special shaped wire. Okay. Forward tube spinning and backward tube spinning. Forward tube spinning, also known as tube stretching. This method means for increasing the depth of cooking pots or the length of cylindrical parts or tubing, and the diameter is constant. The power spinning method is equivalent to shear spinning and forces the metal to flow axially along a mandrel, increasing the length of the workpiece while decreasing the thickness of the sidewalls. While backward tube spinning is the same as forward tube spinning except that the forming tool moves in the opposite direction. It moves toward the headstock of the spinning lathe and the workpiece metal flows away from the headstock. This is an illustration of backward and forward tube spinning. The above one is a forward tube spinning. The roller feed goes into the machine tailstock. While the backward tube spinning, the roller goes into the machine headstock direction. Just like this and this. Only that's the difference. The next one is draw bending. Draw bending used in bending tubing sections and bars. The workpiece is held against a bending form by a shaped clamp. As the bending form, the workpiece is pulled or drawn around the form and against a pressure die whose form also matches the cross section of the workpiece. So this is an illustration of draw bending when the tube is clamped by a clamping die and the bending form or the die rotates. This video gonna show you more information about draw bending works. Now this is the machine rotary draw bender, and this is the workpiece. Now the workpiece is clamped by a clamping die here, and it gets fastened. Now the die here rotates while the workpiece is clamped by the clamping die here, and it bends. That's how draw bending works. Okay. The next one is we're gonna talk about compression bending. Compression bending is similar to draw bending method, but the forming block here and clamp do not rotate. Clamp and forming block do not rotate. Instead, the pressure die is replaced by a wiper shoe or fitted roller which moves along the periphery of the stationary bending form, causing progressive bending of the workpiece. So the difference of compression bending and draw bending is only at the clamping die and the wiper shoe. I'm going to show you the video of compression bending. So the clamping die is here and the wiper shoe moves and rotates to bend the workpiece here. Just like this, the clamping die, and this is the wiper shoe, and this is the block form. ram and press bending. Ram and press bending is a method applicable to the tubing, bars, and other sections. A forming block is attached to the ram of a hydraulic press. Automobile exhaust pipes and other tubing components used in large quantities are commonly bent by ram and press bending method. This is an illustration about ram and press bending, where this is the workpiece and the punch goes here, bringing force to the workpiece, and this is the wiping shoes. The wiping shoes hold the workpiece and the punch giving force to the workpiece so it bends like this. For more clear, I can give you the video. So this is the wiping shoes right here, and this is the punch here. This is the workpiece and the punch giving a force to bend the workpiece like this. Here's the bigger tube. Okay, that's how ram and press bending works. Next one is stretch bending. The stretch bending method is used for sheet metal, also applicable with variations of bending of tubing and other sections. The workpiece is stretched longitudinally to the yield point and then is wrapped around a bending die or form. It's simply similar to the ram and press bending, but the force is from right here and right here, not from the punch. This video gonna explain how stretch bending works. So the force is from this side and this side. The die and that's how stretch bending works. Okay, next, wrinkle bending. Wrinkle bending is a method for bending large, heavy-walled tubing or pipe. It is applicable to field conditions since it can be done by hand with no special tooling. One side of tubing is heated locally by gas torch to the point where the tubing wall softens. A compressive force is applied to the pipe, causing the soft area to wrinkle and the tubing to shorten on that side, producing a shallow bend. Okay, now the roll bending. Roll bending means of putting gentle bends in tubing, pipe, bars, rolled or extruded shapes, plates, and sheets. Usually use 3 parallel rollers with lower 2 being mechanically driven, just like this, and the third placed above and between them. Common application for this method is the production of cylindrical parts, but sheet metal can be produced by roll bending too. There's 2 examples in this illustration. One sheet metal and one tube. Okay, this video is taking a long time, so we're gonna wait. This is the machine of roll bending. Okay, so the workpiece go between them. Now, so this is the workpiece that he's gonna bend. He places it between the rollers here and he fasten it. Now the roller bend the workpiece here. Just like that, the workpiece is bent by the roller. Okay, so we're going to the next one. The next one is roll extrusion bending. This method is used for large heavy walled pipe. One wall of the pipe is wagged from the inside, causing it to elongate and the pipe to bend. Successive bends in different planes can be made with this method, but a straight section must be allowed between bends. Bulging mechanical. Bulging mechanical is an operation that expands a portion of tubular or cylindrical part. When done mechanically, a segmented die with segments held together by springs is inserted into a tubular part. During the press stroke, a tapered punch pushes the segments apart and they, in turn, push out the walls of the workpiece. The process produces a pattern expansion because of open spaces between the die segments when they are expanded. It is bulging hydraulic. Expands tubing pipe or a cylindrical part by applying internal force with a pressurized liquid or an elastomer. Elastomer is low durometer rubber. The workpiece is contained by a die that is split so that the bulged part can be removed after the operation. This drawing is an illustration for bulging hydraulic, where this is the punch and this is the die. And when the punch giving force, the workpiece match with the die pattern. This is the video of bulging hydraulic. Okay, so this is the workpiece that is gonna bulge, and the press of hydraulic punch the workpiece. And the workpiece became the same with the die. You see the difference? The first one is flat, and when the workpiece is bulged, it curves. Yep, it's curved. Okay, let's get into the next one. The next one is the non-shear forming operations, shearing of parts and others non-flat shapes. In this method, alligator shears are commonly used. Wilson shears, vertical presses permanently fitted with short shear blades, are another alternative in shops where there is much bar shearing. This is the alligator shears that's commonly used, and this is the guillotine shears. Cold heading. Cold heading is a process for upsetting the end of a rod, wire, or bar. Upsetting means enlarging and shaping. It is commonly used for the production of bolts, rivets, nails, and screws. Just like this illustration, it product screw. One or more blows of a heading tool against the end of a rod or bar displays some portion to change its shapes and enlarge its diameter. This method is particularly economical when production quantities are large. This is the punch, and this is the workpiece. This is the die. As you can see, the punch has a different pattern. We can choose which one we're gonna use. And when the punch gives force to the workpiece, and this is the result. The next one is thread rolling. Thread rolling is a metal forging process that forms threads into the mirror image of a roller die. The process is different from metal cutting, grinding, and chasing because it does not remove any metal from the workpiece. Instead, thread rolling uses hardened steel dies to displace and mold ductile metals. This is the illustrations of thread rolling. This is the flat workpiece, and when the workpiece goes flow into the machine, it becomes a thread. It's like this. I'm going to show you the thread rolling process in the video. Just like in the illustration, this one is still flat and this one is already become a thread. It spins and it slowly became a thread. That's how thread rolling machine works. The next one is impact or cold extrusion. Impact or cold extrusion forms a part of some length by plastic flow of metal under compressive stress into an opening of limited size. The process is normally referred to as impact extrusion when non-ferrous metals are involved, and cold extrusion when the workpiece is ferrous. There are varieties of the process, such as forward extrusion, backward extrusion, and combined extrusion. Collapsible metal tubes are made with this process. Aluminum, copper, lead, and magnesium alloys are the most commonly extruded along with low and medium carbon steels. And now I'm gonna present about backward extrusion first. Backward extrusion. In this process, a metal blank is placed in the die. Like this, the workpiece, and the metal is compressed by the punch and forced to flow backwards around the punch to form a hollow object. So the hollow ram here giving force to the work, and the work extrude into this direction. Backward extrusion frequently used with softer non-ferrous metal such as zinc, lead, and tin. So this is the backward extrusion. And now I'm going to show you how the video of backward extrusion. This is the hollow ram, and inside of this die is the workpiece. And you need to look closely. There's the workpiece that extrude. Yeah, and this is the result of the workpiece. The result is like a tube. The next one is forward extrusion. Forward extrusion, sometimes is called the hooker process. The workpiece metal flows forward through an orifice rather than upward around the punch. Different from the backward extrusion, the plunger or the ram push the workpiece and extrude into the other direction here. If the plunger push from the left side, and the extruded metal come from the right side, and this is the process. And this is the workpiece here. Now this is the forward extrusion. The ram push the workpiece into the die. And this is the extrude metal. This is the result of this forward extrusion. Now the combined extrusion. Combined extrusion is both forward and backward impact extrusion at the same time on the part. The backward extrusion can have an even solid or hollow shape than the forward extrusion. This is the illustration of combined extrusion. This is the punch, and the punch gives force into the workpiece. The workpiece is already placed inside the die. After the punch giving force to the workpiece, a half of the workpiece goes backward and forward like this. This is the backward extrusion and this is the forward extrusion. And that is how combined extrusion works. Thank you.